Hi, this is Kirsten Bassett,
This is Joey Gottme.
and this is the Kangaroo Crew.
What exactly are we looking for when we run emission spectroscopy?
Well, we're looking for lambda max.
What exactly is a lambda max?
Lambda max represents the wavelength with the largest concentration of emitted photons at a specific substance.
When you record an emission spectroscopy, you receive a peak. The maximum of the peak corresponds with an x value that is lambda max. The position of lambda max on the x-axis represents the wavelength, which in turn represents the color emitted from the substance. What does the intensity represent in emission spectroscopy?
Intensity is the amount of photons being released at a specific wavelength.
So, what is a photon?
A photon is a quantized energy that is released when an excited electron goes from a high state of energy to a lower state of energy.
When an electron relaxes to a lower energy state, a greater difference in energy states corresponds to a smaller wavelength. Because green travels a larger distance, it releases more energy and therefore has a shorter wavelength than the red. The energy that is released from these electrons moving down to the ground state creates photons corresponding to the color of their specific wavelengths. A way to understand energy states is to imagine the electrons existing in these different energy levels instead of traveling to them. The electrons instantly jump from one energy level to another, emitting or absorbing a photon each time.
So conjugation is actually the switching back and forth between single and double bonds in a molecular structure. This can determine the wavelength emitted from said structure. This means that rhodamine B, which has more conjugation, will absorb energy at higher wavelengths and lower energy levels than our green substance, which is shown in the data provided. And it's important to note that you cannot emit more energy than you can absorb. Why are there two peaks on the graph?
There's two peaks on the graph because both the green dye and the red dye have different lambda maxes, which is their differentiating characteristic based on their molecular structure. Now, in our experiment, the green dye had a lambda max at 504 nanometers, and our red dye had a lambda max at 614 nanometers.